Hello students, welcome you to this video. In this video I am going to teach you exercise 7.3. But before that, let us see the concepts, what is required to learn this exercise. So this is factor theorem. Here we are using factor theorem. Already you studied factor theorem in the lower class, right? In a polynomial, suppose p of x is a polynomial. When you put x is equal to 3, if your answer is 0, that is p of 3 equal to 0, then you say x minus 3 is a factor, right? When you put x equal to 1, if your answer is 0, that is when p of 1 equal to 0, we say x minus 1 is a factor. So same way here in matrix, factor theorem we have. If each element of a matrix A is a polynomial in X, sometimes there may be some constant terms, right? That means the coefficient is 0. If each element of a matrix A is a polynomial in X, and if determinant A vanishes for x equal to A, then x minus A is a factor of A. So determinant A is given. So every element is a function of what? X plus 2, something like that. Sometimes some constant also, okay? So like that you have. When you put x is equal to A, if determinant A vanishes, that is determinant A equal to 0. When can you say determinant is 0? If two rows are identical, proportional, one row fully 0, then the value 0. So when expand also you may get what? 0. Then you can say x minus A is a factor. Here another very important thing you have to remember. See, suppose you want to prove x plus 2 is a factor. How can you prove x plus 2 is a factor? In determinant A, you put x equal to minus 2 and check. Wherever x comes, you put minus 2. If your answer is 0, you can say x plus 2 is a factor. If you want to prove A minus 1 is a factor, you put A equal to 1, right? You put A equal to 1. A minus 1 equal to 0. When you solve, you are getting A is equal to 1. Suppose you want to prove x plus 2A is a factor. X plus 2A is a factor you want to get. You put x plus 2A equal to 0, right? So x is equal to what? Minus 2A. You put x is equal to minus 2A. When you put x equal to minus 2A, if determinant A vanishes, then you can say x plus 2A is a factor. Suppose you want to prove A is a factor. You want to prove A is a factor. What do you do? You put A equal to 0. You put A equals 0. If determinant A vanishes, then you can say A minus 0. A minus 0 is same as what? A only. A is a factor. To prove B is a factor, you put B equals 0. To prove X is a factor, you put X equal to 0. To prove A minus B is a factor, you put A minus B equals 0. A minus B 0 means A is equal to what? B. So the substitution what it gives is put A is equal to B. Now listen, another very important thing, a particular case. When you put X is equal to A, in determinant A, when you put x is equal to A, suppose two rows are identical. Two rows are identical, another one we have different elements. If two rows are identical, yes, you can say the value 0 and you can say x minus A is a factor. X minus A is a factor. Suppose when you put x is equal to A, all the three rows are identical. All the three rows are identical, or all the three columns are identical. Then you can say x minus A, the whole square is a factor. If two rows are identical, the value is 0. Three rows are identical also, the value is 0 only. But which is a factor when you put x equal to A? When two rows are identical, you say x minus A raised to 1. X minus A is a factor. If three rows are identical, reduce 1. X minus A square is a factor. Suppose 5 rows are identical. When you put x equal to minus 7, 5 rows are identical. We don't have sums like that for objectives, okay? Suppose 5 rows or 5 columns are identical, then which is a factor? Minus 7, bring it to the left side, x plus 7. 5 rows are identical, so raised to 4. X plus 7 raised to 4 is a factor. Suppose r rows are identical. R rows are identical. When you put x equal to A, then which is a factor? You are putting what? What substitution? X equal to A. So x minus A is a factor. If 3 rows are identical, x minus A square is a factor. 10 rows are identical, x minus A raised to 9 is a factor. R rows are identical, then x minus a raised to r minus 1 is a factor. That's a very simple thing. That's all the concept. Suppose x has two factors, 2, or say one more, 3 factors like this, and 7. So what are the roots here? X equal to 2 root, x equal to 7 root. But this 2 repeats 3 times. So we say multiplicity 3. Because 2, the repeated root, right? The root 2 repeats 3 times. So we can say x equal to 2 is the root of multiplicity 3. Okay, so hope you understood all these things. So now based on that, we are going to do few sums. Some more important result I want to tell you when it teaches the sum, I'll explain. Okay, so please listen. Solve the problem by using factor theorem. So the first question is not to solve, show that. Okay, first question is show that. They will ask some solved questions also. If they ask some solved question, what do you do now? First you factorize. Suppose you are getting 8 into x minus 2 into x plus 2a. You get something like this. Then if you want to solve it, equate with what? 0. They give some determinant equals 0 they give. You try to factorize the left side. You get something equal to 0. Then you are getting x is equal to 2. 8 cannot be 0. X minus 2 0. So x equal to plus 2. Then x plus 2a 0. That is x is equal to minus 2a. Right? Like that you can solve it. But this question is to prove. Show that this determinant is equal to 8abc. Listen very carefully. I'm going to take 2 or 3 questions. So listen. We start with LHS. So you have to use factor theorem. If you use some other method, they won't give mark. Okay. But see this question. Suppose instead of A, if you use B, and instead of B, use C. Instead of A, you put B. Instead of B, you put C. Instead of C, you put A. If there is no change, then we say these type determinant, we call it as cyclic symmetric form. They are in cyclic symmetric form, meaning if you rotate, A you change it as B, B you change it as C, C you change it as A. If there is no change, then we call that form as what? Cyclic symmetric form. If you want, you can change and you can check it. The right side also, A, B, C. If you change cyclically, A become B, B become C, C become A. Then one more time, everything same only you'll get. Okay. So in such cases, what is the specialty here? You prove A is a factor. Once you proved A is a factor, you can say similarly we can prove B and C are also factors. So in some questions we prove A minus B is a factor. Once you proved A minus B is a factor, if they are in cyclic symmetric form, you can say the other two factors without proving. You say similarly we can prove B minus C and C minus A are also factors. After proving one factor, you can prove the other things. Or just you can say similarly. Okay, so now please listen here. See the question is prove that question. 8abc. So you have to prove A is a factor. How can you prove A is a factor? You put A equals 0, right? So before that we take the LHS. I'm giving a name, determinant A. It is B plus C, A minus C, A minus B, B minus C, C plus A, B minus A, C minus B, C minus A, A plus B. Okay, this is determinant A. Now, to prove A is a factor, you put A equal to 0. You put A equal to 0. So, determinant A is equal to, when you put A equal to 0, B plus C, you are giving A 0. So, minus C, A you are giving 0. So, minus B, B minus C, A you are giving 0, right? So, you get only that C. A 0, you are getting B. The last row, A is 0, so C minus B. Next element, A 0, you are getting C. Then A 0, you are getting B. Now, the second column, you can see C is common. Third column, B is common, right? So, BC, you can take outside. First column, no change. B plus C, B minus C, C minus B. The second column, I have taken C outside, so you are getting minus 1, 1, 1. Third column, we have taken B outside, so minus 1, 1, 1. Now we know the properties already the previous video you studied, right? So now you can see the second column and third column are identical, right? So you can say the value becomes 0. The reason you have tried C2 is equal to C3. Now please listen, the determinant value becomes 0 when you put A equal to 0. So by factor theorem, which one is a factor? A minus 0 is a factor. A minus 0 is same as what? A, right? So you can say now, therefore, A is a factor. Now you can say the reason, since determinant A is in cyclic symmetric form, you can say the other two factors, B and C, are also factors. So three factors, you got it? Listen, already we proved A is a factor. Similarly, you can say B and C are also factors. So three factors, you got it, right? What's the degree you are getting now? A degree 1, B degree 1, C degree 1, all multiplication. So add the power. 1 plus 1 plus 1, the degree is 3. Suppose it is A square into B, what's the degree? 2 plus 1, it is 3, right? Suppose A square B C raised to 5, what's the degree of this one? All multiplication, so add the power. 2 plus 1 plus 5, 3, 8. Okay, the degree is 8. But in this case, you are getting only A, B, C. You are getting only A, B, C. So what's the degree now? A means A raised to 1, B raised to 1, C raised to 1. 1 plus 1 plus 1, the degree is 3. Now we see the degree of this, the product of the diagonal elements. First one is B plus C. It is not BC. Please listen. B into C means 1 plus 1, degree 2. But B plus C, separate terms, the degree is 1 only. C plus A, degree 1. A plus B, degree 1. So if we add the degrees here, 1 plus 1 plus 1, right? So that is you are finding the degree of the product of diagonal elements. It is 3. The product, degree of the product of factors, what we proved, that also 3. Both are equal, right? So now I want to teach you something. That's the only thing I left out. So first we are finding degree of the product of leading diagonal elements. Is equal to, that you have to find out. Also you have to find degree of the product of factors. Both you have to calculate. So in this case, first we have calculated the degree of the product of leading diagonal elements. Leading diagonal elements, what's the product here? 1, 1, 1. So it is 3. Degree of the product, the three factors you got, A into B into C, 1 plus 1 plus 1, that is also 3, right? So now you find the difference of these two. Difference is 3 minus 3, greater minus smaller, 3 minus 3 is 0, right? The difference you may get 0 or 1 or 2. In each case, how to do I'll tell you, but when the difference is 0, the difference normally we take it as m equal to 0. When m equals 0, the other factories, no more variables, other factories, there may be a constant. But you know, in the answer, it is a prove that question, you know what's the answer, you are supposed to get 8. You can't simply write 8, right? We have to prove it is 8. So since the degrees are equal, m is the difference is 0. If the difference is 0, the other factor what you can attach is k. So now you may have a question, if the difference is not 0, what to do? After this sum, I'll explain to you, okay? When m equal to 0, the other factor you take it as what? K. Now you substitute here, therefore determinant A, that is the left side you write. What's the left side here? B plus C. So we write the question, right? Okay, so we are getting this is equal to, already we proved A, B, C. Now we attach one constant, what? K. So we have to find K value, right? So this is your answer, only thing you have to find K value. So for that what we do now, we give some substitution. You give, for A, B, C, you give some suitable values. But we want to find K value. So please listen very carefully. We want to find K value. So for A, B, C, you give some values. If you give 0, the calculation will be easy. But if I give A equal to 0, if A is 0, 0 into something totally 0, you won't get K value. We want to find K value, so don't give 0 in this case. Okay, you can't put 0 here. You give some other number, very easy value. You say put A equal to 1, B equal to 1, C is also equal to 1 you give. Okay, if you substitute A value 1, B 1, C also 1. So B plus C means 1 plus 1, it is 2. A minus C, that is 1 minus 1, 0. A minus B, 0. B minus C, 0. C plus A, 2. B minus A, 0. 0, 0. A plus B, 1 plus 1, 2, right? You can give any value, same value give it to the right side also. So K into A value 1, B value 1, C value 1. So here the answer is principal diagonals above the triangle or below the triangle. Any one of the part is 0, then your answer is product of the diagonal elements. 2 into 2 into 2. So 8 is equal to K into 1 into 1. It is what? K. So substitute in the first equation. So you are getting this determinant is equal to K into what is K value? 8. You are getting 8 ABC. Okay. So check the steps. You take the determinant as what? Take the determinant as determinant A. So we are giving a substitution here. We are giving what substitution is given? So we are given the substitution here A equal to 0. What's the reason? Because right side the answer is what? 8ABC. Okay, so we are given the substitution. And the degrees you are checking. If the difference is 0, the other factor is K. Now please listen here. If the difference, if M equal to 0, the other factor is K. That's what we used in this sum, right? Suppose if M equal to 1, what is the other factor? The other factor is you have to take K into A plus B plus C, because the degree you have to get difference is 1, no? So to compensate that 1, you have to add some what? Variable, right? So if A is the A, B, C are there in the question, you write A plus B plus C. If X, Y, Z are there, X plus Y plus Z. K into A plus B plus C. So that the degree is 1 only. You can't simply put A alone. You cannot be partial, right? Give importance for everything. A plus B plus C, a cyclical factor. Okay, so it's totally the degree is 1 only, right? Now, the third one, if the difference is 2, if M value 2, the other factor is little lengthy 1, even the calculation also will be little lengthy 1. So K into difference is 2, degree 2. How can you write degree 2? A square degree 2. A into B also degree 2, no? So both you can give. A square means A square plus B square plus C square. AB means AB, BC, CA. So we are writing K into A square plus B square plus C square plus L into AB plus BC plus CA. This is the factor you have to attach when if the difference is 2. In that case, there are 2 unknowns. In the previous question, we saw only one unknown, K. To find K value, we are given one set of values, right? If there are 2 unknowns, you will be getting something like this, okay? But in the right side, you will be having 2 unknowns. So what you do, no? Like this, you give one set of values for A, B, C. You won't get the answer. You will get one equation in K and L. You will get one equation in K and L. Take it as equation number 2. Give another set of values. Earlier you given 1, 1, 1, no? Like that you give 1, 2, 2, 2, or 1, 2, 3, or you give 0, 1, 2. I said don't give 0 only if it make the right side value 0. Other cases you can give, right? So anyhow, you give one more set, you will get another equation in K and L. You are getting 2 simultaneous equations in K and L. Solve it, K value, L value. Then you have to substitute here. Okay, that is if the difference is what? 2. So 2 set of values you should give. Okay. So that's all. So now we go for the next question. Now straight away we can do that because already we did one question and I explained all the results related to that. Okay, we take the determinant. Determinant A is equal to B plus C, A square, C plus A, B square, A plus B, C square. By seeing the answer, you can decide what we have to substitute, right? Because prove that question. Sometimes if they're not giving the answer, then you have to be very careful, right? If the question is factorized, right? Either A, B, C factor or A minus B, B minus C, C minus A factor, they will give sums of that type only. Even if the question is factorized, don't think how to do that. Okay, any one of that you can try. Okay, now please listen. A minus B is a factor we are going to try. So this is also cyclic symmetric form only. This is in cyclic symmetric form. A, B, C. Cyclically, if you rotate, you will get the same determinant only. Okay, how can you prove A minus B is a factor? What substitution you give? A minus B is a factor means A minus B equal to 0. So A equal to B. So the substitution what you have to give is put A is equal to B. So wherever A comes you put B. So determinant A is, for A you give B. So B plus C. For A you give B. So B square. For A you are giving B, right? So C plus B square. For A you are giving B. So B plus B it is 2B. C square. Can you say the value 0? See the first row, second row, are they same? B plus C plus B, both are same only. Then B square, right? So first row and second row are equal. So you can say the determinant value 0. When this determinant becomes 0, what substitution we are given? We are given A equal to B. So which one is the factor? Bring that B to the left side. A minus B is a factor. So you can say therefore A minus B is a factor. Before writing the other factors, you can say here determinant A is in cyclic symmetric form. So you can say therefore the other two factors A minus B is a factor. So what's the other factor? B minus C. What's the next one? C minus A. A, B, C, A cyclically. Okay. So therefore B minus C and C minus A are also factors. Okay. Now please listen. What's the degree you got it now? A minus B 1, B minus C 1, C minus A 1, 1 plus 1 plus 1, degree 3 you got it. But see the degree of the diagonal. B plus C, degree 1 only. It is not B into C. B into C means 1 plus 1, 2. B plus C, so it is 1 only. Then B, degree 1. C square, degree 2. So 2 plus 1, 3 plus 1, 4. So degree of the leading diagonal elements is equal to what? 4 here, right? So degree of the leading diagonal elements is 4 here. Degree of the product of the factors, you got 3 factors, A minus B, B minus C, C minus A, 1, 1, 1, it is 3. So the difference M equal to 4 minus 3, so the difference is 1. The previous question difference 0, so the other factor is just K. Now the difference is 1, so you can say therefore other factor is K into A plus B plus C. So the other factor is K into A plus B plus C. Now we have to find that K value, right? For that we have to give the substitution. So before that, so we write the LHS. So this is the question equal to, already you got which factors you got it? You got A minus B is a factor, B minus C is a factor, C minus A is a factor, and now we have taken K into A plus B plus C is also a factor. This is your answer, right? And we have to find K value. But by seeing the question, you know, nothing is there. That means K value you are supposed to get 1, right? But we have to prove it. Simply you cannot write. The previous question we got K value 8, right? So here we have to prove K value 1. So for that you give any suitable substitution for A, B and C. In the previous question I said don't give 0. Because A into B into C. 0 into anything it is 0. Our aim is to find K. Right side should not be 0. Here, what you can give, you know, A and B don't give same value. For A, B and or B and C or C and if I give same value, 2, then 2 minus 2 is what? 0. So don't give like that. You can put 0. A equal to 0, B equal to 1, C equal to minus 1 or 2, something you give, right? So both the sides you substitute. B plus C means 3. Then A value 0, A square also 0. Then C plus A, 2 plus 0, 2, B value 1, B square 1 square 1. A plus B it is 1, C, 2, C square, 2 square is 4. Equal to the right side K into A minus B, minus 1, 0 minus 1, minus 1, B minus C, 1 minus 2, minus 1, C minus A, 2 minus 0, it is 2, A plus B plus C, add everything, you are getting what? 3, right? Now simplify. You have to expand it. 3 into, leave the row and column, 4 minus 2, Then other two zeros, because 0 into 0 into, so everything 0 only. Right side minus into minus is plus, 2 3s are 6, so you are getting 6k. 4 minus 2 is 2. 2 3s are 6, so 6 equal to 6k, you are getting k equal to 6 by 6, it is what? 1. So now we got all the everything, k value got it. Substitute the first equation. When you substitute the first equation, this is equal to, already we proved a minus b is a factor, b minus c is a factor, c minus a is a factor, k into, now k value 1, k into a plus b plus c. Okay, so hence proved. So we are substituting here. K value you are giving 1. So 1 into a minus b, it is what? A minus b only. So that is your answer. Okay, hope you understood that. Now let's move on to the next question. Look at this question. Show that, okay, I am taking the determinant. Determinant a equal to 1, 1, 1, x, y, z, x square, y square, z square. Very simple question. Listen. So here, factor theorem you are using x minus y. So put x equal to what? Y, right? X minus y 0 or put x equal to y. Wherever x comes, you put y. So determine a equal to first row 1, 1, 1. For x you give y. So y, y, z. For x you give y. So y square, z square, right? Y square, z square. The value becomes 0. Can you say the reason? First column and second column are identical. First column is equal to second column. 1y, y square, 1y, y square, right? First columns, two columns are identical, so the value becomes 0. When you put x equal to y, you are getting 0. Bring that y to the left side. X minus y is a factor. So you can say x minus y is a factor. Now similarly, you can write the reason. Determinant a is in what? Cyclic symmetric form. That steps you write. Similarly, now I am writing straight away. Similarly, we can prove y minus z and z minus x are also factors. Okay, now please listen. X minus y, everything got it, right? Now there is just one only, some constant, right? Please listen. What are the steps you are right? Degree of the product of the leading diagonal elements. That steps you are right. 1 is a constant, so degree 0. Y degree 1, z square degree 2. So 2 plus 1, 3 only. Degree of the leading diagonal elements 3. Degree of the product x minus y 1, y minus z 1, z minus x 1, 1 plus 1 plus 1, that also 3. M is the difference. 3 minus 3 is what? 0. So what is the other factor? The other factor is what? K, because the difference is what? 0. The steps you are right, okay? The other factor is K. So you take the LHS, right? You take LHS and therefore let this determinant is equal to, already we proved x minus y, y minus z and z minus x are factors. Now the other factor is what? K. And we have to prove k value is what? 1, right? We have to prove k value 1. See that for that what substitution, like previous question, you put x equal to 0, y equal to 1, z equal to 2. When you substitute, equation 2 become 1, x value 0, 0, 0 square. Second column 1, y value 1, y square, 1 square is 1 only. Third column 1, z value 2, z square, 2 square is 4. Equal to, right side also substitute k into x minus y, 0 minus 1, minus 1, y minus z, minus 1, z minus x, 2. Hope you understood. Now when you expand using the first column, 1 into, leave the row and column, 4 minus 2. Other terms will be 0. 1 into 0 minus 0, or this 1 into 0 minus 0 only. Using first column or first row you do, you will get the same answer. Minus into minus is plus, you are getting 2k. 4 minus 2 is 2, 2 into 1, 2. So 2 equal to 2k, or you say k equal to 2 by 2. So k equal to 1. K value 1, substitute the second equation. K value you put what? 1. So that k you can leave it, right? So x minus y. So your answer is, this is equal to k value 1 only, that 1k leave it, x minus y x minus y into y minus z into z minus x. Okay, hope you understood this. Even if the difference is 2, you can do that like this. Here you got directly k value, right? But in that case, you won't get k value directly. You will get one equation in what? K and L. Any two letter you use, k and L or L and M, whatever it is. Then you give another set of values. Here we give no, like this, instead of 0, 1, 2, you give 1, 2, 3, something like that. You will get one more equation in K and L. The two simultaneous equations, you solve it, then you have to substitute. Okay. Already I said, if it is a solved question, after factorizing, you put equal to 0 and equate each factor with 0, right? And you can solve it. Now, example sums also you can practice. The sums what we left out, you try to work it out, okay? Because factor theorem, any sum let them give you should score full mark, okay? Easily can do that. Look at this one question from example. It's a repeated question, so one of the very important question. So Q, instead of A, B, C, they can use X, Y, Z, or they can use P, Q, R in this question, whatever it is, right? So determinant A given, right? Determinant A is this one. Determinant A is equal to Q plus R the whole square, P square, P square, Q square, R plus P the whole square, Q square, R square, P plus Q the whole square. Now please see the right side using that. First we have to get P is a factor. How can you prove P is a factor? Put P equal to 0. Yes. Put P equal to 0. When you put P equal to 0, determinant A become, wherever P comes you put 0. Q plus R the whole square. P value 0. So 0, 0, Q square. P value 0. You are getting R square, Q square. Next R square, P value 0, you are getting Q square. Second column, R square is common. Third column, Q square is common. First column, write as it is. Q plus R the whole square, Q square, R square. 0, 1, 1. Again 0, 1, 1, right? So two columns are identical. C2 equal to C3. 0, 1, 1, 0, 1, 1, right? So the value becomes 0. When you put P equal to 0, the answer is 0, determinant is 0. So you can say therefore P is a factor. So now we can write the reason. Since determinant A is in cyclic symmetric form, you can say Q and R, right? Q and R also factors. Now please listen, P is a factor, Q is a factor, R is a factor. But still you have P plus Q plus R, the whole cube. If P plus Q plus R alone means no problem. Degree, suppose, then here degree 4. If the difference is 1, K into P plus Q plus R you will get. But here P plus Q plus R, the whole cube is there, right? So now what do you do now? Put P plus Q plus R equals 0. We have to prove P plus Q plus R is a factor. So equate that with 0. So determinant A is equal to, listen very carefully this step. So this is determinant A, right? Determinant A. Wherever you have two elements, you simplify. Q plus R. See what is Q plus R from here? From here you find out what is Q plus R. Q plus R is minus P. So here what you are getting, minus P the whole square. Minus P the whole square means it is P square only, right? Other two elements, P square, P square. Second row, first element is Q square, last element also Q square. First element is Q square, last term also Q square. See the second term, what we have, R plus P the whole square. From here you find R plus P, R plus P. R plus P is equal to minus Q. So when you put minus Q here, minus Q the whole square, it is Q square. Same way, last will be R square, R square, R square. When you go for the examination, you should be thorough, don't waste time. All they prove that question, standard questions, right? You can write very easily. Now you can see all the three columns are identical. C1 equal to C2 equal to C3. Don't say R1, R2, R3 equal. They are not equal. P square, P square, P square, Q square, Q square, Q square. They are not equal. If you want, you can take P square outside, Q square outside, then 1, 1, 1, 1, 1, 1. Last also R square outside, 1, 1, 1, right? Or you can say proportional, you can say. Okay. But identical straight away. Column 1, column 2, column 3. All the three columns are identical. Factor theorem, we studied one result, no? If 2 rows are identical, value becomes 0, x minus a factor. 3 rows are identical means x minus a square is a factor. If 10 rows are identical, x minus a raised to 9 is a factor. That when you put x equal to minus a, right? When x equal to a, then x minus a is a factor. Here, when you give p plus q plus r, you are getting 0. Not only getting 0, all the 3 columns are identical. Therefore, p plus q plus r, the whole square is a factor. Because 3 columns identical, row or column. P plus q plus r, the whole square is a factor. Now let us see. Now let us find the degree of the product of diagonal elements. That is leading diagonals, understood. Leading diagonal elements equal to, see that one? Diagonals here degree 2, here degree 2, here degree 2. 2 plus 2 plus 2, it is 6. Degree of the leading diagonal elements is 6. Next you write degree of the product of factors. First we proved P is a factor, D1. Then similarly Q and R, 1 plus 1 plus 1, degree 3. But now we proved P plus Q plus R, the whole square is a factor. Already P, Q, R, degree 3. Now P plus Q plus R square is a factor, degree another 2 more. So 3 plus 2, 5. What is the difference? Difference is 1 now, right? Difference equal to 6 minus 5, which is equal to 1. So you can say the other factor is, if the difference is 0, it is k. If the difference is 1, k into a plus b plus c, if a, b, c are in the question. K into x plus y plus z, if we have x, y, z. Here we have p, q and r. So the other factor is k into p plus q plus r. Okay. Now listen, you substitute it in the question. So you copy that question. We take that LHS, we substitute. So this is equal to, already we proved P, Q, R are factors, right? P, Q, R, and here one more, P plus Q plus R, the whole square we proved. P plus Q plus R, the whole square is a factor we proved. But now what you are getting, the other factor is k into P plus Q plus R. So one more P plus Q plus R. Already here P plus Q plus R square. Now this one more P plus Q plus R, together P plus Q plus R the whole cube, and we have a k also. So this is your answer, and now only one unknown. The unknown is k, and you know the unknown you have to prove it is equal to what? 2. Now let us see. For that, give the suitable values. You can't put 0 here, right? 1 you can give. So put P equal to 1, Q equal to 1, R also 1. So Q plus R, 1 plus 1, 2 square, 4, 1 square, 1 square, 1 square, R plus P, 1 plus 1, 2, 2 square, 4, 1, 1, 1, 4, equal to, right side simplify, K into 1 into 1 into 1. Here 1 plus 1 plus 1 the whole cube. So 4 into, simplify, leave the row and column, 4 4s are 16 minus 1. Take the second number minus 1 into that row and column, 4 minus 1 plus 1 into 1 minus 4. Right side is k into 1 into 1 into 1, leave it. 1 plus 1 plus 1, 3, 3 cube is 27. So here 16 minus 1, 15 into 4, 60, minus 4 minus 1 is 3, minus 3. Here 1 minus 4 is minus 3, so minus 3 equal to 27k. 60 minus 6, 54 equal to 27k. So you are getting k equal to 54 by 27 cancels exactly 2, k equal to 2. Now k value got it. Now what do? You substitute here, right? So substitute in the first equation. The first equation is this one. Only thing, k value, that k value got it now. What is k value? K value you got it as what? 2. Instead of k you write 2, and this is your final answer. Okay, hope you understood this. With this idea you practice the remaining questions. We'll continue the next class.